All right, you guys, so we're going to solve this linear system by elimination, and this is the same system that we've already solved first by graphing. So we graphed each line that's in the system and saw the point of intersection, and then we solved the same system using substitution method, and then today we talked about elimination method. So we're going to solve that same system using elimination method. Now remember, the goal of elimination method is to be able to eliminate one of the variables so that you can solve for the other variable. So we can either try and eliminate x or eliminate y by adding our two equations together. For that to work, we need either the coefficients of x or the coefficients of y to be opposites of each other, like 2 and -2, 3 and -3, 1, -1. So looking at these two equations, I have a few options here. So I could multiply the first equation by a -3, and that would work. Or I could multiply the second equation by a -2 to make the y's eliminate. So I'm going to multiply the first, I'm just going to do the first option, and I'm going to multiply the first equation by a -3. So then we can rewrite the system as -3x minus 6y equals to -18. And the second equation in this case has stayed the same. Okay, so we used our multiplication property of equality and multiplied the first equation in the system by -3 on each side of the equation, so that now we can see that our x terms, the coefficients on the x terms in each of these equations, are opposites of each other. So we can just add straight down. In the examples in class, I was rewriting the system, so I'll do that again. Okay, and now we're ready to add straight down. One thing I forgot to say at the beginning is you first want to make sure that your x's are lined up vertically and your y's are lined up vertically, and then the constants are lined up vertically to be able to add straight down. Okay, so now adding -3x plus 3x would be 0x. -6y plus y gives me -5y. And -18 plus a -2 is -20. So now notice that, like in substitution, remember in substitution method, we did the substitution so that we had an equation in a single variable. But now that we've been able to eliminate the x terms, we have an equation with just a y in it. So we can finish isolating y by dividing by -5 on each side of the equation. So we get y is equal to +4. So we still need to know what x is. So we know that the y value of our solution will be +4. And we can substitute 4 into any of the equations above. So in the original system or the other system where the first equation has been multiplied by a -3 in order to solve for x. I'm going to actually substitute 4 in for y in the very first equation of the original system, so this guy right here, so that I can just see that x there has a leading coefficient of 1, so it's going to be the least amount of steps to solve for x. So I would have x plus 2 times 4 is equal to 6. So that's x plus 8 equals to +6. And then subtracting by 8 on each side of the equation, we'll end up with x is equal to -2. So our solution, again, since we use this system for other examples, we could see is -2, +4. 4. So this is a consistent system because there's exactly one solution. We could always do our check, but we did our check in the other video. So now we've solved this system using the 3 different methods that we have talked about.